Okay, so last time we went through and talked about just a really brief introduction to what the idea of statistics is and how information is gathered, the different methods for that. We talked about some misuses or some bad ways to use statistics, just really surface level. So today, if you remember, we were talking about the idea that statistics has a bunch of different areas, and one of the areas is how do we organize the data. So today, that's what we're going to be talking about. We're going to talk about different basic ways to organize the data, how to draw a couple good graphs, and that's what the day is going to take us. Hopefully we'll get through this whole section in one sitting, but if not, anything that we don't do today, we'll throw at the beginning of next time. We've got plenty of time because the very last section of this unit is pretty short. So we got plenty of time for questions if you have them. We got plenty of time for the material. So what we're going to talk about today is what's called a frequency distribution. And then we're going to use a frequency distribution to introduce a couple different types of graphs that you might see in statistics. They're kind of the most common graphs that you see when you're thumbing through Instagram or Twitter or anywhere else that you might encounter graphs. You're going to see stuff like this. So first, before we get to the graphs though, what is a frequency distribution? So frequency distribution is in general just going to be a way to organize our data so that we can kind of get an idea of what's going on all at once. So I'm going to show you what it is through this example, and then you're going to give developing a frequency distribution a try on your own. So this first one says the following data represents family income in thousands of dollars of 15 randomly selected families. So we're just keeping the data set small because we're just learning about these things, and so that makes it nice and manageable. So we're going to construct a frequency distribution. And the first thing you have to see is that the first class of the distribution is going to be all the data from 31.5 to 37.6. So some terminology here for you is that this 31.5 value, we call this the lower limit, the lower class limit. I don't think that's too mysterious, but I just want to make sure that when I refer to these things and I use these words, that you know exactly what I'm talking about. The 37.6 in this class is the upper class limit. Now, if you take a statistics class, you'll go into a little more depth on this, and you'll be told where these classes come from, because depending on how many different divisions of your data you want, the classes can either be wider or narrower. It just depends on how you want to see the data. Okay, so just a couple things about the classes that you need to know. When you make a frequency distribution, your classes, they do not overlap. That's super important. You don't want any piece of data to be able to fall into two different classes, because then that messes up your being able to see what's going on. And then the classes are all equal size. If classes are not equal size, then what happens is you can have you have a more likelihood that a value will fall into one class versus the other. Okay, so far all you know is a little bit of terminology. So in your homework, on your quiz, on your test, when I ask you to do a frequency distribution in this class, I will give you the first class. Okay, so that is a different discussion for a different class on where that comes from. That's not what we're going to get into here. But once you get the first class, here's how you make your frequency distribution. What we're going to do is we're going to make a column for income. Okay, and that's where we're going to put our first class. So 31.5 through 37.6. And then once we get all of our classes lined up, because we need enough classes to span this whole set of data, once we get that, we are going to go through and we are going to look at what the frequency is that something occurs in each class. Okay, so here's the most important step for you. So if you have not been paying attention up till now, time to turn on the listening ears. Most important step for you. Oh, perfect timing coming in, because I'm getting to the most important step of making a frequency distribution. Okay, so if my first class here is 31.5 to 37.6, and I've told you that classes do not overlap, what would you propose? Make any sort of guess. We'll determine. What would you propose is the next lower limit going to be of the next class? What did you say? I didn't hear. What did you say? Yeah, so if this is the highest part, if this is the highest value in this class, 37.6, then the next value would be 37.7. Okay, the next 10th. I go from, I just count 37.6 to 37.7. That's going to be the next lower limit. And the reason that is the most important thing for you to understand and be able to discern about making your frequency distribution is now that you have two consecutive lower limits, you can determine what's called the class width. I'm going to define that for you because this is the most commonly missed part of making a frequency distribution. Once you can get this, making one is, I don't think, really a big deal at all. Okay, so the difference between two consecutive lower limits is called the class width. I'm also going to put in parentheses the difference between two consecutive upper limits is also the class width. So the class width for this right here, if you got your calculator, you can help me out here, is just going to be 37.7 minus 31.5. I've just taken the difference between these two consecutive lower limits. And what is 37.7 minus 31.5? My calculator somewhere. Thank you, 6.2. Woo, appreciate that. I'll grab my calculator to help you out. Okay, so that's important. Here is what the class width is not. Okay, I want to help you avoid a mistake, because this is the most common mistake that students make. Everything else about frequency distribution, students do great at. Here's the mistake. The class width is not the difference between the upper and the lower. Okay, if so, 37.6 minus 31.5, and if you got 6.1, that is not the class width. That's going to create classes of unequal sizes. Okay, class width is the difference between two consecutive lower limits in this case. Once you've got that, we've got 6.2. Here's how you get all the other lower limits and all the other upper limits. Okay, everything just kind of tumbles into place. I'm going to take this value, 6.2, the class width, and I'm going to add it, and I'm going to get all the upper limits. So help me out. If I have 37.7, what do I get when I add 6.2 to that? 43.9? And what I'm going to do is I'm going to create classes until I get to a class that's bigger than my biggest piece of data. So what's the biggest piece of data in this list? Let's see. I've got a 65.2. Is there something bigger than that? No, that's the biggest one. So let's keep going. What do I get when I add 6.2 to 43.9? 50 what? 50.1. Thank you so much. I'm going to do it again because 65.2 is still bigger than that. What do I get when I add 6.2 to that? 56.3. 65.2 still is bigger than that. So what do I get when I add 6.2 to that again? 62.5. Great. You're doing really great. Well, we're getting pretty close to 65.2. What would I get if I added 6.2 again to that? 68.7, did I hear you right? Well, 68.7 is bigger than my biggest piece of data, so I do not need that class. So I'm going to stop. So I just want to summarize because this is the most important part. Once you can do this, you can do it all. So I give you the first class, 31.5 to 37.6. Then you just used counting from elementary school to say, oh, if 37.6 is the biggest thing here, then 37.7 has to be the next one. And then I used that 37.7 and 31.5 to get the class width. We did that subtraction up here. And this is just all of, I just keep adding 6.2. And now I'm going to do the same thing for the upper limits. I'm just going to keep adding 6.2 over and over. So again, if you could help me out, when I have 37.6 and I add 6.2, I get what? Perfect. Which, by the way, notice 43.8, this is a nice check to make sure you're doing things well. That's 43.9, so nothing is overlapped. I'm good. What do I get when I add 6.2 to 43.8? Okay, 50.0. And then when I add 6.2, I can do that one without a calculator, 56.2. And then 6.2 to that gives you 62.4. And finally, 6.2 plus that gives you, excellent. And now I've got my classes. You're going to go through that same process on the next problem, or in fact, the next two problems, just to make sure we're practicing it. So then once you've done that, once you've got the classes, that's the hard part. The next part is I'm just going to now see this data is out of order. Okay, so and that's why I gave a small set. I'm not trying to torture you. I'm just trying to teach you a little bit about math here. And so what we're just going to do is we're going to see where does each piece of data fall, which class. So I'm just going to go through this. 46.5 is in this class. So I'm just going to make a little mark. I'm just counting. Okay, this is called a tally. If you don't want to do that, that's fine. I'm going to cross out the pieces of data as I go because I lose track real easy because I'm scatterbrained. 65.2 is down here, so I'm going to make a mark. Do you see what I'm doing here? How I'm keeping track? If I lose you, please let me know. 35.5, going to make a mark right there. 31.8 is in this class, make a mark. 52.4 is in this class, make a mark. 40.3 is in this one. 45.8, third class. 44.6 is in the third class. 39.8 is in the second class. 44.7 is in the third one. You still with me? Am I losing anybody? I'm just tallying up where the values are. We doing okay? Okay. 53.7 is in the fourth class. 56.3 is in the fifth. 40.9 is in the second. 48.8. Now, the thing about a tally, you don't have to do this, but I would go blind if I had to count up dozens of little lines. So the standard practice is every fifth one you do a cross so that you know you have a group of 5. So it's easier to count when you're done. So that's the 48.8. And then last but not least, 50.7 is in the fourth class. And so now I've done my income column in my classes. The only other thing is my frequency column. I just count up the tally. So in the first class, I had 2 marks, so 2. Second class, I had 3 marks, so 3. Third class, I had 5 marks. Fourth class, 3 marks, and then 1 and 1. And it's called a frequency distribution because it's just telling you the simple fact of how many times a piece of data falls in each of the different classes. All right, so I'll give you a second to catch up with the writing there because I know I got a little excited and went fast there at the end. But below that, you have example 2. I've given you another set of data. The nice thing about that set of data is it's all in order. It makes the tally a little easier to do. So I've told you the first class of the next one is 12.0 to 15.9. So you're going to use that first class in order to create all the other classes. So I'm going to give you 2 or 3 minutes. If you need me, wave your hand. I'll come around to you, help you get started on that problem so that we can all be on the same page. Okay, so let's get started here and see how you're doing, how you did. If you got any questions about anything that's still not quite cement solid in your brain, that's great. So I've given you the first class. So this data represents populations. So I'm going to make the first column population. And that first class is 12.0 to 15.9. And then the other column is going to be frequency. So now, again, I'm just going to talk you through. You're going to help me with this because I want to make sure that we're making the right decisions. If the upper limit is 15.9 of this column, what's the next value? What's going to be the next lower value? 16.0. It's just counting. After 9 comes 10, so that makes this 16.0. What do I use these two? What do I use these two lower limits now to find? You're going to subtract. It's called the class width. Okay, so right over here on the side, I'm going to find the class width. And the class width is 12.0. Oh, no, it's not. Sorry, wrong order. It's 16.0 minus 12.0. And your calculator is going to tell you that's 4. So far, so good? We're going to do another one in just a minute so that if you didn't quite get all that the first time around, maybe it'll lock into place and you get it the next time around. So now I'm going to use this 4.0 class width to make enough classes so that I can accommodate my largest piece of data, which is 38. Okay, so when I add 4 to this, I get 20. Add 4, I get 24. Add 4, I get 28. Add 4, I get 32. Add 4, I get 36, a lot of classes. If I was to add 4 more, I'd get 40, and 40 is bigger than my largest piece of data, so I do not need another class. I'm going to do the same thing on the upper limits. I'm just going to keep adding 4, so 15.9 plus 4 is 19.9, plus 4 is 23.9, so this was a nice class width that was a little easier to add to everything, 31.9, 35.9, and then 39.9. And in all honesty, I mean, that's a difficult thing to do. You're learning it, so it's mysterious. But once you know how to do that, that's the difficult part of making a frequency distribution. The rest of this is just counting things up. So since the data is in order, I'm just going to do some counting. How many values are between 12.0 and 15.9? Okay, so let's see. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. How many values do I have from 16.0 to 19.9? 16.6. 1, 2, 3, 4. Great. We're good. Everybody see where these values are coming from, where I'm counting? 20 to 23.9. How many? 1, 2, 3, 4, 5, 6. Yeah, that's a lot of values. 24 to 27.9. How many? Just that one. From 28 to 31.9. 0. Now we do include those. Okay, so you wouldn't erase that or delete it. That does give you information if you're somebody looking at this. It tells you that what it tells you about this distribution is everything is front loaded. There's a lot of smaller or quote unquote smaller cities than really large ones. Okay, 32 to 35, again, there's 0 of those. And then the last value, that 38, is in this last one, so 1. Now, what you don't do, we do include these 0 frequencies that are in the middle. We do not add on extra ones when they're zeros. You always stop once you're out of data. Okay, so I would not put on another class of 40 to 43.9 and say that's 0. There's no need for it. And there's your frequency distribution. Before we move on, I'm going to give you another one to do. Is there a question that you have? Yeah.
All right. So for the population,
Mm-hmm.
I had 12 through 15.9.
Right.
All right. So for the left side, I understand the add 4 from the class width. How do you get from 15.9 to 19.9?
Same thing. The class width applies. Every one of these values on the left, all these lower limits, they're all 4 apart, right? All of these over here, they are also all 4 apart. So I just added 4 repeatedly again.
All right.
Yeah, no problem. Great question. I love questions, so always ask them. Okay, so next page, you're going to do another one. Okay, so this set of data is the ages of 44 volunteers at a food pantry. Again, it's out of order, so that makes the count at the end a little more inconvenient. But set up your frequency distribution and get as far into it as you can. Notice there's no decimals. All of my data is whole numbers. So when you do the next class, you're sticking to whole numbers. Okay, so yeah, I was gonna ask this beautiful question because the other two had decimals, and so we were using decimals. So notice the reason I'm making this decision is all the data here is whole numbers. There's not a decimal to be found. Okay, so I've got 42 to 47. So what did you propose as the next lower limit? Yeah, that's beautiful. That's exactly what you would do. The next value is going to be 48. It would not be 47.1 because I don't have any decimals. So that would be adding more detail in than I would need. Yep, that's exactly what it would be. Okay, so probably the most time-consuming part of this is the count, and I don't think that's difficult at all. So I just want to make sure that we're getting the classes together because that's the most important part. So 42 to 47, you've already told me that the next lower limit is 48. So that means what is the class width of this problem? Yeah. Always remember, I'm just going to repeat this because it's really honestly the only thing students miss about this on the test is the class width. So if you can remember this, you're good. The class width is the difference between the two consecutive lower limits, always. Okay, so it's 48 minus 42, which is equal to 6. So I'm going to use that now, and then my oldest age, my largest value here, what do I've got? Okay, the largest one is 69, great. So we're going to make enough classes to accommodate that. So when I add 6, I get 54. When I add 6, I get 60. When I add 6, I get 66. And if I added 6 more, I would get 72. And 72 is bigger than my biggest piece of data. So I don't need that next class. That's all my lower limits. And then just again, to reiterate the answer to the question that was asked earlier, how do I get the upper ones? Same way. You just add 6 to all of to the upper limit. So 47 and 6 becomes 53. Plus 6 more is 59. Plus 6 more is 65, and plus 6 more is 71. And there's all of our values. However you choose to count, if you don't like my tally method and you just say, hey, Perkster, it's a little easier for me to go through and I'm just going to cross out all the ones that are from 42 to 47, that's great. There's probably quicker ways to do it. In all honesty, this is just the way that I was taught, and it allows you time to process and think. So I'm just going to run through this, and maybe you're already done. You can just watch and be entertained, I guess. So I'm just going to go down the columns. So 57 is here, and 61, and 57, another 57, and 58. So I'm done with the first column. Then another 57, so that makes a group of 5. 61, 54, 68, 51. That's the second column, 49, 64, 50, 48. This class is starting to catch up. 65 and 52, 56, 46, 54, and 49. That's the fourth column. Here's the fifth column, 50, 47, 55, another 55, 54. That class is really popular. 42, 51, 56, 55. You can see that this is just the time consuming part, but there's really not a whole lot of thinking involved. Then 54, 51, 60, 62, almost done, 43. This is just exciting for me as it is for you. This column here, 55, 56, 61, 52, 69, that largest piece of data, 64, 46, 54, and then finally 47. Boom. Whew. Okay, so now the important part though, however you did it, okay, whether you did a tally like I did, whether you just went through and crossed it out, or if you had some other method that works for you, this is what this column should be. So the two things I will grade on the test is that you have the right classes and that you have the right frequency. This is just my scratch work that I'm counting up. It is not a required part. So you can do that in a different way. So there's 6 things in this class, there's 11 in this class, there are 17 in this class, 8 and 2. There we go. That's my frequency distribution. It tells me how spread out the values are. All right, there's one more. There's a kind of a special situation that you might encounter. So I'm going to do this one along with you. This last one, example 4, this is our last frequency distribution that we will do. It says the number of children per family is recorded for 64 families. Thankfully, this data is given to us in number order. Construct a frequency distribution with a class width of 1. I underline that. So I've got a class width of 1. I've got all whole number data. There's no decimals. Okay, this would be a little different if I had some decimals involved, but it's just all whole number data. So when you see that special instruction class with 1, what they're wanting you to do is this. What I'm going to do is my classes are not going to be ranges now. Since it's all whole numbers, you know, I don't have any decimals or anything. I'm just going to make my classes to be equal to the values. So I've got 0, that's going to be a class, and then 1 is going to be a class, and 2 all the way up to 9. And I just have enough room on my paper, so good job. Okay, so this is just a special situation. You see this a lot. Oh, by the way, I gave you that assignment that to find, you know, you can find me 5 bad graphs or bad uses of stats. And I went on Twitter after class yesterday, and right away, staring me in the face was a bad economic graph that had a bad scale to it. And so they're out there, easy to find. So just look around, and you'll be able to get those. You'll be able to get those points. Okay, so my frequency, I'm just going to count up. And so how many zeros? So there's, let's see, 1, 2, 3, 4, 5, 6, 7. There's 8 those. So the rest is just counting. How many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, there's 11 of those. How many 2s? There's a lot of 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 2s, 3s. 11. How many 4s? 6. How many 5s? We're declining in frequency. 1, 2, 3, 4. 6s, there's 2. 7s, there's 1. 8, there's 2. And last but not least, 9. Somebody was really busy. There you go. I had some friends that had 12. That was amazing. I don't even know how you, I guess at some point you're just like, okay, now I got kids to raise the kids. So you just, whatever. All right, so there you go. Are we okay on frequency distributions? I think once you learn it, it's not too difficult to thing, but I understand that there's some detail there that is tough. So that's kind of the first big thing. The other big thing of this section, now that we've learned what a frequency distribution is drawing a picture to go along with that frequency distribution. So there's a couple different types of pictures that we're going to have. So example 5. We are going to do 2 things. We're going to do them one at a time. I'm going to do what's called a histogram, and then I'm going to have you do a histogram, and then we'll come back and we'll do the other thing, which is called a frequency polygon. These are the 2 most common types of graphs you will see when you are looking at any sort of pictures of data wherever, textbook. There are others, but these are the most common ones. A histogram is just a fancy math word for a bar graph. So what we are going to do is we're going to do a histogram for the frequency distribution that we created in example 1, the very first example. So here's what you're going to do. So keep this in mind, because what you're going to do, your next assignment is in example 6, you're going to construct a histogram for the frequency distribution in example 2, okay, the one that you did. So the first thing that you're going to do is you're going to draw like a big L. This is your X and your Y axis. I'm going to draw a big L right here. This is where we're going to draw the graph. And I'm just looking back to page 1. On page 1, our value, or what we were looking at, is income, and we had frequency. So what you're going to do on your histogram, the Y-axis is always going to be the frequency. And in this case, the X-axis is going to be income. Whatever you're measuring becomes the X-axis. Are you with me so far? Okay. I'm looking back on page 1 again. On page 1, I see that my frequencies go from 1 to 5. So I didn't have huge things. So however you label the Y-axis, it just has to be in equal increments. I'm going to use 1s because I don't have too many. So I'm just going to do 1, and then 2, and then 3, and then 4, and then 5. If you have larger numbers, you can go by 2s or 5s or whatever. Just make sure you're counting the same increments. Okay, that would, if you didn't, that would make it an example of a bad graph like we talked about last time in class. I'm going to go back to page 1. And I see on page 1, I have, no, that's not page 1. Here's page 1. I have 1, 2, 3, 4, 5, 6 classes. So on the income down here, what I'm going to do is I'm going to put 6 equally spaced marks. So 1, 2, 3, 4, 5, 6. 1 for each class. Don't label them yet. Okay, now I know some places do this differently. People get lazy about their graphs, but this is a math class, so we're just going to be mathematically correct about this. And if you learn in a teacher class, or if you're in an economics class or somewhere else, and there's different parameters, then that's totally fine. But the way math people label their histograms is we use what's called the class mark. Which is also called the class midpoint. What we do is we're going to label the midpoint of each of the classes. We're not going to write the range of values down at the bottom. We're going to label the midpoint. And so how do you find the class midpoint? That is a great question. I'm glad you asked it. What you do to find the class midpoint, I'm going to go back to page 1, is you say, okay, here's my first class, 31.5 to 37.6. I'm going to add those two values up, 31.5 plus 37.6, and then divide by 2. Okay, we're just getting the middle. So 31.5 plus 37.6, and I'm going to divide by 2. And if anyone's got a calculator, you are welcome to give me the value. I will. What was that? Okay, so that's 34.55. So I'm going to turn my graph sideways, and that first mark is going to be 34.55. So now you might be thinking, well, what do I have to do from there? Do I have to do that for every class? That seems like a lot of work, and it would be a lot of work. You can do that, but I'm going to take a shortcut. I'm going to remember that what was my class width from example 1? It was 6.2. So I'm now going to use that in my calculator, and I'm going to get all the other midpoints. So 6.2 is my class width. So I'm going to turn my graph again, and if you can help me, so when I add 6.2 to 34.55, I get what? So 40.75. That's the next one. Then I add 6.2 again, and what do I get with the next one? Perfect, 46.95. 6.2 again is going to give me 53.15. You're doing great. We've just got 2 more. 6.2 again is, and then one more time. Whoops, that's a 6, 65.55. Excellent work. I'm going to give you a second to get caught up. That's the hard work of the histogram. Once you've done that, you are almost done. The fun part is the last part. All we've got to do is draw our bars. If you remember what we said last time about bad graphs, just remember our bars have to be the same width, okay? Because the area of the bars gives us something. So flipping back to the first page, the first frequency was 2. So I'm just going to draw a bar that straddles this mark that goes up to 2. So up, up, down. There we go. Did you have a question? You got it? Awesome. The next frequency, again, I'm just turning back to page 1 where we did the frequency distribution. The next one goes up to 3. So again, I'm going to draw a bar that straddles this mark that goes up to 3. And bars, in a properly done bar graph, the bars touch each other. So the bars should be equally spaced, and they should touch each other. The next one is 5. So again, I'm going to draw a bar that straddles this third mark and goes up to 5. So it's the tallest one. And then the last ones are 3 and 1 and 1. So 3, again, go up to 3, over, and then 1 and 1. If you had a bar that was at 0, then you just would skip it. You wouldn't draw anything, and you'd go to the next one, and you'd leave a gap, like when your teeth fall out. It would look like that. Okay, so then we have 1 and 1, though. We don't have 0 this time. So 1 and 1, and there's my histogram, my bar graph that represents the frequency distribution. So again, remember we talked last time. Why do we draw pictures? Because we're visual people. The picture tells us a lot before we even know the numbers. So you can automatically see how this data is spread out. You can see where the majority is focused in there. So you've already got information that your brain is processing before you even know what the numbers are. So I would like you, I'm going to give you a couple minutes. If you need me, wave your hand. I'm happy to help in however I can. Example 6, you're going to again go back to the front page, and you're going to do the histogram for the bar graph, or excuse me, you're going to do the histogram for the frequency distribution there. Yeah. If it was 0, I would not have a bar here, but I would leave an equal space. Okay, I'd leave a gap right there. Yeah, great question. And use the password to get online.
different from the population, so like the regular problem. So with this problem, why is the population different from the background?
How is the population different? I'm not
Or is
understanding.
it just the midpoint of all of them?
It's just the mid value between the
Okay.
lower and the upper of that class. So you're right, it's not a value on the chart,
Mhm.
but it's telling you what the midpoint of that range of values that represents the ones we put in there.
Okay.
Okay.
Oh,
Okay, so I'm going to get started. Let me know if you got a question. So here's my L. I noticed on our frequency distribution, the highest frequency was 8. So I just counted by ones. But if you counted by twos, that would work as well. We've got 7 classes. And my class mark for the first class is 13.95. So I'm going to put that right here, 13.95. And if I'm remembering, our class width was 4. Is that right? So I'm just going to now add 4 to that. So I get 17.95 and 21.95, 25.95, 29.95, 33, and then last 37. Everybody with me so far? Anybody got something different? Do we need to talk about anything? At this point, the rest is just drawing the bars. And so I go back to the front. I've got 8 and 4 and 6. So 8. So again, I just draw a bar that straddles this mark all the way up. So I don't know that I can draw straight, so you have to forgive me. So 8, and then I've already forgotten what the next one was. 4, was it? Okay, 4. Remember, my bars are approximately equal width because I'm drawing freehand, but they touch each other. And the next one's 6. And then what do we have? 1, 0, 0, 1. 1. And then, as I said, these next 2 classes that have a frequency of 0, I just skip them. And then over here, I'm going to draw one that's 1. So I've just got a bar peeking up out of nowhere right there. There's my frequency distribution. Okay. So far, are we so good? Okay, if you can do the hard work for the frequency distribution, there's almost nothing different about a frequency polygon as far as the setup. So I'm going to slide my sheet right back. What I would like you to do, I'm going to do it. You can do it at the same time. Some people draw these both on the same grid, but I don't want to create a big mess and possibly impede your understanding. So I'm just going to redraw my shell here, the L and the frequency and the income, and then I'm going to stop and I'm going to wait for you because instead of bars, a frequency polygon is something different. So I'm just going to draw the same thing we did. So the good news about a frequency polygon is there's almost nothing new for me to learn here. All right, so I'm going to give you another minute or two just to finish rounding that out and getting that drawing done. Okay, so once you've got the shell of this down pat, here's how you do a frequency polygon. So whatever I ask for on the test, your first step is the same, whether it's a histogram or a frequency polygon. The second step, instead of drawing bars, here's what I'm going to do. We're going to draw a dot. above each class mark. So the first one was 2, so I'm going to put a dot right there. The next one was 3, so I'm going to put a dot right here. And then we went up to 5 with the next one, so a dot, and then back to 3. And then the last ones were at 1 and 1. And then there's 2 things you're going to do. First thing, the fun thing, you're going to connect the dots like you're in kindergarten. So here we go. I'm going to connect the dots. So whee. Now that's a line graph and they have their uses, but in statistics, because there's a relationship with area, like if you took a statistics class, you would begin to talk about the relationship between area and probability and likelihood of things happening. So what statisticians do is this left-hand point, that's the first point. We're just going to now connect it over here to the origin. And this right-hand point over here, that's kind of sitting there. We're going to draw just kind of an equidistance down to the axis right there. We create a closed figure, a polygon that you could calculate the area of. So that we're not going to get as much into that in this class, but that becomes an important thing as you go along the area. So that's why this is some pre-statistics stuff. So please do the same thing for your example, example 6. Going to give you a minute or 2. I know that probably the most time-consuming thing is just drawing those, the X and the Y axis again. All right, so I've drawn my X and my Y axis exactly as I did for the histogram over to the left. And so now I'm just going to draw dots instead of bars. So the first one was at a level of 8, and then at a level of 4, then a level of 6, then a level of, 1. The next ones are at 0. So I'm just going to make a dot right there on the X-axis for each of those, and then a 1. Okay, so if you didn't know what to do with the zeros, I understand, that's okay. And just learn from that. You just make a dot right there on the axis. And so now I'm going to connect those dots in order. So like this one's going to go down to the X-axis. This one's just going to cut across, and then it's going to finish up in the air like that. And on the left side, again, I'm going to take this leftmost dot and I'm just going to connect it down to the origin. And I'm going to take this rightmost dot and I'm just going to go out to a little bit out there, and it creates like a little triangle out to the side. Okay, so I've got, well, we could probably finish the section in 14 minutes, but we're just going to do one more example each. We'll get to a nice, comfortable stopping point. You can do most of your homework. You could probably figure out the last couple problems, but we'll do them when we come back on Tuesday. So, if you don't get all the way through the homework. Okay, so sometimes you want to create a picture of your data, but maybe you don't want to draw. You want to do something really quick. There's a nice, useful little tool. So here is some data that we have. It represents the ages of 20 guests who stayed at a bed and breakfast. So it's just some made up data. What we're going to do is we're going to create what's called a stem and leaf display. And so a stem and leaf display actually does not involve picture. The value of a stem and leaf display when you have just a small amount of data is you actually retain the values of the data, because as was mentioned, was part of your question, is even though I know the frequencies, I don't know what any of the values are. Okay, I know I have 8 values in this bar, but I don't know what those 8 values are. So a stem and leaf display will retain the value. So here's what we're going to do. We're going to create a column from the stem, and then we're going to create a column for the leaf. We're going to draw, and we're going to draw like a bar between them. So like that. Maybe draw yours straighter than mine. Mine looks like it was on a roller coaster or something when I drew it. And so the way you do a stem and leaf display is this. Your leaves are going to be the last digits of the data. The stems are going to be everything else. So we just got 2-digit data because we're just learning and it's our first example. So what I'm going to do is I noticed that my lowest value is, looks like 28. I got 27. So what I'm going to do is I'm going to create a stem for all the things that start with a 2. And then my data goes up and I've got a high piece of data of 72. So I need to have stems that go all the stuff in the 20s, all the stuff in the 30s, all the stuff in the 40s, 50s, 60s, and 70s. And then your leaves, you just do a list of the values of the second values. You put them in number order. You do not need to separate them with commas or anything. So for instance, in the 20s, I've got a 29, I've got a 27, and a 28. So I'm going to put a 7 here. I'm going to put an 8, and I'm going to put a 9. And so that tells me, if once you learn how to read a stem and leaf, it tells me, okay, I got the value 27, I got the value 28, and 29. So I'm going to cross those out so I don't count them again. I don't think I have anything else in the 20s, so I'm done. In the 30s, I've got 31, I've got 39, I've got 32. That's it. So I'm going to put a 1 and a 2 and a 9. By the way, if values repeat, then you repeat the leaves. Okay, that gives you the frequency. Okay, in the 40s, we've got 43, 47, a pair of 44s and a 45. So I've got a 43, cross that out. Pair of 44s, so put 2 4s there, 1 for each of the 44s, a 45, and then I think I said there was another one, didn't I? 47, thank you. You have better short-term memory than me. There it is. The 50s, I see right away I got a 50, so I'm going to put a 0 there, so I don't have to remember it. And then I've got a 56, a 58, and a 59. So 56, 58, 59. Everybody see what's going on and how I'm putting my values down in there? Okay, it's pretty straightforward, but I know we're just learning this. I don't want to assume anything. 60s, I've got a 60, a 62, a 68, so 0, 2, and 8. And then last but not least, I've got my 70s. I've got a 71 and 72. So notice you've retained your data. You also can get kind of, if you turn it on its side, you kind of get the impression of a bar graph. So you can kind of see the distribution of how things are laid out as well. So you get a little bit of the best of both worlds. Stem and leaf displays are not good when you have a large set of data because because you'd have huge lists of numbers and it'd be hard to work with. But for small sets, it works. So here's our last problem for the day. Top of the next page, example 8. It's just asking you to please do a stem and leaf display for that problem right there. Yeah, try your best to put the leaves in number order. Yeah, that, because again, that helps you see frequency if things are repeated and stuff like that. So that would be the proper way to do it. Okay, I'll give about another minute to scribble down as many values as you can. Then we'll finish this up. Okay, so I noticed that my low value was 10. My high value looks to be 62. So I needed stems from 1 to 6. Just as an aside, because I don't know if this happens on the homework, but it happens in real life. Let's say I had a single digit piece of data. Let's say I had the value 8. Does anyone have a hypothesis of what I'd make my stem for the value 8? Yeah, 0. There'd be no 10s, so you'd put a 0 there. Excellent, great job. Okay, so my stems here, so I've got 10 and I've got 17, and so I'm going to put a 0 and a 7 right there. Oh, I also got a 15, so let me make that look like a 5, and then we'll put a 7 right there. So there we go. My 2s, well, we got 24, 24, another 24. I just see 2 24s. Anything I'm missing there? Okay. And then 3s, I got a 36 and a 30 and a 33. Anything I missed? 40s, 48, 45, 42, 48 and 45 again. So I've got a 42. I've got 2 45s. And then I've got 2 48s. 50s, I've got a 53 and a 54. And last but not least, 60s, I got a 60, a 60, and a 62. So 0, 0, 2. And there is my stem and leaf display.